My name is Marek Fořt, and I am a software engineer at Shopify on the React Native Foundations team. And I hope everybody still has some left energy for the last presentation, which will be about FlashList and about how you can make a list fast now. So this is a tweet from Mark, and it reads, "What if React Native ends up holding us back?" Hold us back. What are you rendering? A list of cards with text in them. Now, of course, this is a bit of an over-exaggeration, but there is this sense in the community and outside the community that lists still pose a foundational problem to create performant apps. At Shopify, we've also hit issues with FlatList and especially on low-end Android devices, where, as you can see, the FPS is non-existent and we have huge blank screens, and this isn't just not the user experience we want for our users. So we need a faster list, FlashList. But wait, what about RecyclerListView? Why build a new list when there are other alternatives in the community? So the advantages of RecyclerListView are that if you implement it right, it actually is really fast, especially compared to FlatList. It is also highly customizable, so you can achieve almost any layout that you would want to achieve. And it is also very well tested. It has been around in the community for a bunch of years, and it has been used in production by small and large companies. But it has also a couple of shortcomings. Especially the API is quite complicated. The API surface is really broad, and while you can achieve almost anything with it, it also means that the learning curve of using this list is quite steep. Swells with dynamic heights also pose quite a bit of a problem if you are not able to compute their height in advance. And during a first render, there are also layout spaces, which manifest as either spaces or when items overlay each other. Okay, so RecyclerListView doesn't cut it for us, so let's build FlashList. The main goals of the projects have been primarily around performance and developer experience, which comes down to high frame rate, UI and JS FPS, and also being able to minimize display of empty items. And, as I mentioned, a good developer experience, so it must be easy to use. So the FlashList API we've come up with is this. It is very similar to FlatList. A lot of the props are the same. This makes the migration extremely easy. You don't have to relearn what you've already learned with FlatList. And we also consider FlatList API as a good developer experience, so we did not feel like reinventing the wheel. Dynamic heights, no sweat. You can use the same FlatList API and still get really high performance. So how, and maybe why, is FlashList so fast compared to FlatList? Maybe let's start looking at how FlatList works under the hood. It uses a concept called virtualized list, which in a sense means that here we have a couple of items that are displayed on the screen, labeled as viewport, items 4 to 6. And then we have a couple of items that are in memory that the user has already scrolled past through. And then we have a couple of items as well that are preloaded. With FlatList, the number of items in memory is generally pretty high. But if you scroll far enough, you also get into a point where you want to free up some memory. And that's where virtualized list comes in. And instead of removing the items, it just takes the item and removes all the content but keeps the size, so the list kind of doesn't change its scroll position. Now this means that the memory footprint is at a manageable level, but as we scroll, up and down, it doesn't matter. Unless the item is already in memory, it's always rendered from scratch. And that means creating a lot of objects again and again, which is not the most efficient process. As a visualization, you could imagine these IDs as instances of individual cells, and as we scroll, we just keep creating new ones and new ones. Okay, so to sum up, FlatList uses virtualized list that replaces cells with empty content to keep the memory footprint somewhat low. And as we scroll, cells are always rendered from scratch. So FlashList, on the other hand, has also, of course, a couple of items in the viewport, 2 to 4 here. It has a couple of items as preloaded, although the amount of them is usually very low. The default is 300 pixels of draw distance. And then, most importantly, there is a concept of a recycling pool. And so, as we scroll, the items are put into the recycling pool, and then when we need to load more items, instead of creating them from scratch, they are put out from the recycling pool and into the list, and they are just re-rendered. That means that, for example, if only a title changes between individual items, you re-render only that title, and you don't need to create a whole new JavaScript object, and you don't need to also create any new native view instances. As a showcase of this, you can take a look at this example. As we kind of scroll, we get to see that the items are put into the recycling pool. And as we get to items that are not preloaded, we start putting the items out of the recycling pool back into the list, and they are just rendered with new content. And so the cell IDs here represent the individual instances, not the content itself. We also needed to fix an issue of the first render. This is how RecyclerListView manifests this issue. So this is a slowed down version of it, but you can see that the items in the first render are kind of over each other. And then after RecyclerListView gets the actual sizes, it puts the items as they should be, and they are not overlaid over each other anymore. To get deeper into this problem, on the left you have the expected layout. So RecyclerListView has a prop called estimated item size, which you as a developer have to input, so the RecyclerListView has a sense of how big the items will be. So in this case, let's imagine that the item size would be, for example, 100. And so it puts number 0 at 0 pixels, number 1 at 100 pixels, number 2 at 200 pixels, etc. But then we have the actual layout where item number 1 has a height of 200. But the item number 2 still assumes that it was 100, and so it puts it a little bit higher than it should, and thus we have the visual regression that we've seen in the example. What we've introduced to cover for this scenario was a native view that synchronously goes through the layout and with a custom algorithm goes through any possible spaces or items overlaying each other and kind of makes up for these regressions. So with FlashList, we get no lag. So the FlashList implementation, we have an API that is extremely similar to FlatList, although there are some props that do differ. We have a native view for the first render, and we've been able to achieve performant dynamic cell heights. And additionally, we do use RecyclerListView as the inner engine, but we built on top of it to achieve that API and also bring more performance out of the box. So let's get into some metrics. The metrics have been collected with a device, Motorola Moto G10, that has a very slow processor, Snapdragon 460, and also there have been recording on the background. So don't look at the absolute numbers, but I do recommend looking at the comparison between FlatList and FlashList. So let's first look at FlatList UI and JS FPS using the performance plugin that we've already seen a couple of times at this conference. So as we start scrolling, we get to see that the JS FPS drops very low, and UI FPS doesn't stay close to 60 as well. And at the end, we get to a score of 39. Average JS FPS is 11.8. Average UI FPS 44. And also, quite importantly, we get almost 2 seconds of thread lock, of JS thread lock, which means that for almost 2 seconds, user has not been able to interact with the screen at all. And we also believe this example kind of showcases a normal kind of complicated list. We have some remote images and a couple of elements in each item. We have dynamic heights. So if we look at FlashList, we never get that low with the JS FPS, which is quite important. And the UI FPS, only for a split second, actually drops under 50. And so we get an average JS FPS of 49, which is over 4 more times better than FlatList. We get UI FPS of 58, which is pretty close to 60. And quite importantly as well, we get no thread lock compared to almost 2 seconds. We also measured blank spaces with a custom plugin that you can check out on the Shopify React Native Performance repo. And as the name suggests, this plugin gathers the average blank space and the absolute blank spaces over time. So with FlatList, even though we, for a couple of seconds, can't even interact with the screen, we get these huge blank spaces that basically span the whole screen. And so the average here is close to 200. And as I mentioned, sometimes it spans the whole screen. With FlashList, on the other hand, we get a different story. The blank spaces are almost eliminated, and they never get to a point where you just cannot see anything. So we are around 45 of average here, with scrolling, I believe, unnaturally fast, which if we compare it to FlatList is basically 7 times better, which is quite an improvement when considering that the only thing we did was change a name of the list. And I would also like to do a quick demo. I am curious to see how it's going to break, but we will see. So we again have a Twitter sample here that you could have seen in the previous videos, and it's currently implemented with FlatList. So we conclude the performance is not good enough. We want to do something better. So what we're going to do is just add the package to our demo. We will install it. Since we do have a native view, we would have to also run React Native, run Android, or run iOS with pod install. But I've already done that, so we don't wait here for 3 minutes. The next thing we're going to do here is we will rename FlatList to FlashList. And we're going to remove this import since we don't need it anymore. And okay, so that's it. We have a couple of props here, so it's not like the list has only one prop. We have a header, we have a key extractor, which, as a side note, is not necessary for FlashList, but it does help in some scenarios. But we do give it a warning, so let's display that. It tells us that the estimated item size for FlashList prop is not defined. I've already mentioned this prop, and in FlashList, this prop is used only during the initial render to get a better idea how many items it should render. And so if you give this item, if you give this number too low, then FlashList will try to render too many items, and the first render can take a little bit longer than it should. The good thing is that based on the items we already have, we can already get the number. So it tells us that we can use a number of 149. I'm just going to round it up, and let's do 150. And when we refresh, we can see that we no longer have any warnings, and we could use this list in production already. One thing we've seen a couple of times as well is that users sometimes have a key in their top-level item components. So let's try to imagine we had this kind of regression and put a key here which is based on the ID of a tweet. This means, performance-wise, that we no longer have any benefits of recycling, since whenever the key changes, the whole component unmounts and we have to mount a new one, so the recycling goes in vain. One thing that's always good when doing any kind of performance metrics is to get rid of the JS dev mode, so I'm just going to do it there. And we do have a hook that kind of helps you also with getting better numbers out of your components, since we do provide some metrics out of the box. So we have a hook that's called useBenchmark, and it has a couple of parameters. One of it is a FlashList ref, so we'll provide that. Oops. Yeah, Copilot, thank you. And we also need to have a model, and I think I'm missing an import as well. Okay. All right, and now we can just pass it to FlashList and to the benchmark. The other thing we need to pass to useBenchmark is a callback, where we'll need to process the result that the benchmark gives us. So one thing we could do is display an alert, because we are we are not in a dev mode, so any logs will not show up. And we also need to rename this. And the result has a couple of parameters, but what we're going to use is formatted strings. We just want to display it. Last thing this hook gives us is an on-blank area callback that we need to pass to FlatList as well. And I believe that should be it. So what this hook will do is it will try to scroll as fast as it can all the way down and up, and it will gather metrics for us. So let's see how we fare with the key parameter. And as you can see, it's not very good. We get lots of blank cells, and the FPS the average is 5. So, yeah, not really good. We also get a blank area that's maximum, I believe, the height of the device, and we also get the cumulative blank area as it went through the list. We also get a couple of suggestions. One of those is that my average JS FPS is low, which I agree with, and it tells me I should optimize my components, which is fair. It also gives us other suggestions, like the data count is low, because you kind of want to have a lot of data to get more stable numbers. So we do have a hook to just multiply the data, so you don't have to do that yourself. Other suggestions here are, for example, that the estimated first item offset can be set to kind of get a better estimate for that first render, and also for a better initial scroll index. And it has a more precise estimated item size based on the large number of items, which we could set to 160, but I will skip that step. So after lots of thinking, we'll find again this key. We will just remove it, and let's see what the results will be without it. So again, the hook will go through the whole list as fast as it can, and again, try to get it metrics. We get from an average FPS to an average FPS of 30. Considering this is a low-end Android device, I am doing recording, and also I'm scrolling unnatural scroll. That's quite good. And also with the key, that's probably the performance you could expect with FlatList. So 6 times better. I believe that's quite an improvement when we've just changed the name. And so let's get back to the presentation. Is FlashList production ready? Let's get this question out of the gate. So let's compare how our shop app looked with FlatList and how it now looks with FlashList. Before it was almost at the point of unusable, whereas now it is extremely snappy with just minimal blank cells on a very low Android device. So if you use iPhone, then you will not see any blank cells for sure. It is also currently used in all of our apps. So it's used in Shopify Mobile, Shop, Inbox, and POS. So we've tested it quite well at this point, and we've also heard a lot of good things about it at this point from the community. So we do believe it is production ready. But if you do have some additional feedback, feel free to share it either here or online. And you can also check out the project as it's open source on GitHub. So give us a star, open an issue, open a PR, and that's it from the presentation. Thank you very much.